You'll hear a lot of noise in the bottom of the shaft. These pieces are falling 850 feet.
Well, this tunnel is about 300 meters long and mainly in rock.
All of us start to realize the infrastructure that we have is too small for our current needs.
Hi, welcome to the Sustainable Region. I'm Vanessa Timmer. I'm outside the Capilano pump station, perched on the cliffs beside the Cleveland Dam. Let's head on inside. We're going to be spending most of today underground as we look at some of the amazing infrastructure lurking beneath the surface of our region. These massive pipes are the beginning and end of an incredible journey. Water from the Capilano Reservoir will be pumped from here all the way to the Seymour Capilano filtration plant. The water flows back by gravity and then heads out to the homes on the west side of Metro Vancouver. In our first story, we take a look at the building of the tunnels that make all of this possible. Another load of muck is being dumped above ground at the access shaft to the Twin Tunnels excavation for the Seymour Capilano filtration plant.
We call it the access shaft because everything that's being built goes through this shaft, and also everything excavated being taken away through this shaft.
The shaft is 11 meters in diameter and 180 meters deep. Workers take an elevator to the bottom, where the temperature is a constant 6 degrees. At the bottom of the shaft, a perpetual rain falls, the result of the cold air from the surface meeting the warmer underground air. A grate opens in the floor of the access shaft, allowing the muck bucket to be lowered into position. Rail cars carry the granite from the tunnel head, which is dumped into the muck bucket to be hauled to the surface. Every day, about 67 carloads of granite are excavated. Each train load is 5 cars and represents 1.5 meters progress. The work proceeds under the watchful eye of the patron saint of miners, Saint Barbara. In her hand is a Davy lamp, which was used to detect methane gas in the early history of mine work. Special diesel engines, with scrubbers to reduce emissions, carry the workers from the base of the access tunnel to the boring machines.
We are in the passenger car of the train that's on its way from the Seymour shaft to the front of the excavation. The excavation front is approximately 4.8 kilometers from the Seymour shaft. This train ride is going to take us approximately 20 minutes.
The work goes on 24 hours a day, 2 shifts of 10 hours for the boring, and 4 hours for maintenance.
But it's way too high of a gauge in there anyways. It should only be at 50 or 60 psi.
The machines are 600 meters underground at this point, just a little bit west of Grouse Mountain.
This is the tunnel boring machine, approximately 18 meters in front of us. There is a cutter head that actually excavates the rock. The cutter head turns, it crunches the rock gets scooped up and it gets put into the conveyor belt. The conveyor belt takes the rock to the back of the machine where it gets dumped into those cars.
The boring machines have large grippers on either side.
In order to move the machine forward, we need to apply the huge amount of force through these grippers into the side wall that allow us to continue excavation forward.
Goran Oljaka, the senior engineer on the project, pays particular attention to the tunnel surface. Each crack and fissure has been mapped and entered into a massive database.
Tunnels are being excavated to granite, The quality of the rock varies from really good that does not require any support to the some of the support at the crown of the tunnels, to the support with wire mesh and the bolts that comes down to the spring line of the tunnels. Some of the weaker sections have even steel sets erected to support the rock.
As the maintenance crew finish their work, the next shift of miners arrive to begin boring. The boring machines move forward about 20 meters a day. Tunneling was completed in 2011. Water will be filtered and treated at the plant in 2013. Water spills dramatically over the Cleveland Dam in North Vancouver. It has held the stage among Metro Vancouver's monumental engineering feats for almost 60 years. That's about to change. The new kid on the block is literally on the block. The western end of it, that is. Twin 7.2-kilometer-long tunnels have been cut through the North Shore Mountains, from the Seymour watershed to the Capilano Reservoir. Upright shafts connect the tunnels to the surface. One of the underground tunnels will convey raw or untreated water from the Capilano source to the water filtration plant in the Seymour area. A second parallel tunnel will convey treated water back to the Capilano area, where the water will be delivered to communities in the western part of the region. Engineer Goran Ojaka has been with the project for close to a decade.
What we have behind us, we have two raise bore machines doing the shafts for the Capilano end. We have two shafts. One is for untreated water and one is for treated water.
A raise bore system is used. A powerful drill creates a narrow pilot hole that meets the tunnel below. A 4-meter cutter head is attached to the drill. The raise bore then begins pulling upward, with the cut rock falling down to the tunnel.
We're at the Capilano site where we've been raise drilling these shafts to connect to the tunnels. Started drilling, raise drilling actually the week after Christmas.
Amid rumbles and screeches in the cabin housing the boring machine, the operators oversee the boring 24/7.
That's a 200 horsepower motor. And it's going through a good sized gear reduction, of course. Right. And it takes a heap to make that thing turn. And you can't see it, you know. I can't see nothing. And all you gotta do is go off your gauges.
As the machine is raising the shaft up 2 to 3 times a day, the machine needs to stop, pause, and remove the section of the shaft to carry on the excavation.
I'm a driller's helper, and I pull the steel off as the raise bore, the reamer is pulled up. The steel's behind me. There's 180 of them in there, and we just pull them off. I love it. It's great. It's working outdoors, which I like, and get to do at our own pace. Well, actually, the pace of the rock and the drill.
The cutter head was visible when it awaited assembly. The rock is scraped by these cutting plates. The last time crews set eyes on the cutter head was almost 3 months earlier and 270 meters below ground.
There are a number of cutters on the cutter head that are crunching the rock, chipping the rock.
But I'm going to guess we were probably drilling an hour and a half a foot in that neighborhood, but it was granite all the way.
Down below, the stones fall into a gallery at the tunnel end. They call it muck.
There is equipment down there that scoops the muck excavated and loads it up into the cars that are pulled by the locomotives to the Seymour side. The material is being deposited in the Lower Seymour Conservation Reserve.
It is late winter 2011, and crews are anticipating the first surface breakthrough of one of the shafts. Below this yellow tarped raise bore engine is where the milestone will occur.
For us, it's quite exciting because it represents completion of a portion of the work that's important to us.
What will be happening is as the concrete begins to break, the water will slowly go away.
It takes about 2 hours as water seeps through the cracks. The reamer has mere inches to go. The work crew and camera crew watch on as cracks appear on the shaft's surface.
You'll see a lot of movement in the concrete, and then when it finally does go away, and hopefully it does successfully, you'll hear a lot of noise in the bottom of the shaft. These pieces are falling 850 feet.
Then, in about a minute, the reamer head comes roaring through. A few photos, smiles, then work resumes. The second shaft still has to have its breakthrough milestone moment. Welcome back to the Sustainable Region and our look at Metro Underground. I'm in the Capilano pump station, and this is a pump. There are 8 of these here, each capable of pumping 330 million liters of water per day, which makes this one of the biggest pump stations in North America. Together, these pumps have about the same horsepower as a cruise ship. But thanks to our mountain reservoirs, our water is mainly delivered by gravity, and these pumps are just to get the water to the filtration plant. In our next story, we look at how new technologies are changing the way we build the pipes that bring the water to your tap. The waters of False Creek look serene and calm, but below the surface, something remarkable has taken place. In November of 2006, a contractor started boring a tunnel here, part of an ambitious Metro Vancouver project called Jervis Force Main No. 2. The pipe used for the original Force Main, No. 1, was actually put there as a water main back in the 30s. The technique then was simple. The pipe was installed across the surface of False Creek and filled with water, forcing it to sink. 7 decades later, that was a strategy that simply wouldn't float.
Just imagine that we are going to dredge and excavate it and put in a pipe. It will disturb, the seabed and the microorganism and biology in the whole area. We decided on the other method simply because, we won't disturb, the biology in the water as well as on the seabed.
This time around, a technique known as horizontal directional drilling was used, so as not to disturb the marine life and other flora and fauna residing in the creek.
We drill under False Creek with a steerable drill bit. We have a sensor right behind the drill bit that allows us to determine the location in 3 dimensions, and we can actually steer the drill bit.
On the Vanier Park side, work was also underway. The pipe that would eventually go into the tunnel was being assembled.
We lay out, the pipe on the ground in Vanier Park in 2 sections, and then we pull the pipe in one piece. The entire 365 meter long, high density polyethylene pipe was pulled in one go.
Once that took place, pipe was installed south on Chestnut Street up to 1st Avenue, then along Pine to south of 4th Avenue, using traditional trench construction methods. It was then necessary to build a second section of tunnel onwards to 8th Avenue, where the sewer line was simply too deep, lying 20 meters below the ground. A geotechnical engineer was brought on board to monitor the structural integrity of the project.
Well, this tunnel is about 300 meters long and mainly in rock. So excavation is going to be in sandstone, mudstone and a bit of coal. Coal itself is quite weak, so stability could be an issue. We need to assess the situation and perhaps provide tunnel support a bit closer spacing than it normally is.
This tunnel was constructed using a machine called a road header, which eliminates the necessity for an exit shaft because tunnel debris can be efficiently removed through the entry shaft. Once the tunnel is complete, rails are being used to move pipe into place. Engineer Reginald Musana is on scene to oversee this phase of the project.
They are lifting the pipe with the crane that you see behind me. They are dropping it in the shaft. From the shaft, it's carried by a flatbed car on tracks, and it transported to where they want to lay the pipe.
At $24 million, the Jervis Force Main project is a pricey but necessary stopgap measure. Until the municipalities can complete the lengthy and expensive process of separating stormwater from sewage, combined sewer overflows caused by heavy rains are a problem that will need to be addressed.
The new pipe is actually connected to a different sewer than the old pipe. It's connected to a sewer on 8th Avenue. And what that will allow us to do is reduce combined sewer overflows into Burrard Inlet by moving the sewage into the 8th Avenue interceptor, which will give it priority conveyance to Iona wastewater treatment plant.
The original force main will likely be used as a backup to the new one, which is considerably larger. It's intended to keep up with growth in the West End and downtown Vancouver for the next 50 years. But engineers concede it's hard for taxpayers to appreciate the value of something they can't see.
Metro Vancouver spends millions of dollars a year constructing these tunnels and sewers to provide these necessary services to the community. And people take it for granted. They flush their toilet, their sewage goes away, and they're happy. And it's their tax dollars at work underneath the ground there delivering this service.
Welcome back to the Sustainable Region, where I'm standing beside the Capilano Reservoir and across from Metro Vancouver's new energy recovery facility, which when it's up and running will recover some of the energy in moving massive amounts of water to homes across the region. All that water will pour into this building and through a turbine to generate electricity, enough electricity to power 800 homes. We'll look around here in a bit, but next we're going to the Port Mann Bridge, where crews are tunneling under the Fraser River. Metro Vancouver is blessed with some of the best tap water in the world. It comes from 3 reservoirs: Capilano, Seymour, and Coquitlam. The regional water main system brings the water to homes and businesses and Metro's member municipalities. Right now, Metro Vancouver is planning a new water main under the Fraser River, just downstream of the Port Mann, the bridge that links Coquitlam and Surrey. This new water main will be much larger than the existing Port Mann water main to accommodate growth in the municipalities south of the Fraser River. The new water main will also be able to resist a major earthquake. First, 2 shafts are built about 60 meters deep, one in Surrey near 116A Avenue and Surrey Road, and the other in Coquitlam's Maccabeak Park. The new main will be constructed in a 1-kilometer-long tunnel underneath the riverbed. Using the shafts for access, a tunnel boring machine, or TBM, will create the tunnel. It's like a large mechanical mole with cutters in front to dig away the soil. During tunnel excavation, precast concrete rings will be installed to provide support. Then, welded steel water main pipes can be installed in the excavated tunnel. Once completed, the new Port Mann water supply main will eventually be connected to new mains on either side of the river. For more information, visit www.metrovancouver.org and search Port Mann Water Supply Tunnel. Welcome back to the Sustainable Region. I'm inside the Breakhead tank of the Energy Recovery Facility, right by the Capilano Reservoir, and the acoustics here are lovely. Listen to this. Ah, ah. Water pours into here after passing through the generator, but it's very high pressure, and so the pressure has to be reduced before heading into the system. So if you look way up this pipe, you'll see a bunch of valves, and these valves help drop the pressure before the water enters into this chamber. For our next story, we're going to look at pipes of a different kind as we tour a factory that makes the pipes that deliver wastewater to our sewage treatment plants. It is a project of massive proportions.
The South Surrey Interceptor project starts at 64th Avenue and Highway 91. It follows the panorama escarpment around to 152nd Street and Highway 10. The current phase we're working on is $30 million worth of construction, so the entire project will be over $100 million.
Right now, Metro Vancouver is twinning just over 3 kilometers of the existing South Surrey Interceptor as part of a 10-kilometer project. This pipe will take sewage from the sewer mains in Surrey, Langley, and White Rock and carry it through to the secondary treatment plant at Annis's Island. The large diameter pipe being used on this project is custom manufactured at a factory in Chilliwack.
The 120-inch diameter concrete pipe, which is 3-meter inside diameter by 3-meter lay length, weighs approximately 54,000 pounds, or 27 tons. That would be equivalent to approximately 12 or 13 minivans.
Why so big?
All of us start to realize the infrastructure that we have that was put in place 30, 40 years ago is too small for our current needs. And there is no expectation, I believe, in the Lower Mainland and within Metro that there would be a reduction in the amount of people moving here.
Simply put, population growth means that older, smaller pipes just can't handle the increased amount of material going into the system. Increasingly, regional authorities are asking for pipes that are 3 meters or 10 feet in diameter. The pipe for the new South Surrey Interceptor is being installed using a methodology that up until now has been untested in the Lower Mainland.
The contractor on the South Surrey Interceptor project has selected a rather unique method of installing this pipe. What he does is he builds an access road into the job site, and that access road will become the bedding for the pipe. In that manner, he's reduced the amount of truck traffic needed to construct the project. He's able to use the pipe bedding as a driving surface, so he saves money not having to build an access road. And Metro Vancouver benefits from this because by shaping the bed to fit the pipe, we actually get better bed support for the pipe.
And the pipe itself is manufactured using unique methods. The Langley Concrete Group invested more than $3 million in large diameter pipe equipment, like this machine. It produces a metal cage that's used to reinforce each section of the pipe. the concrete process is also fascinating. Believe it or not, the cement used to make the pipe that's coming out of this mold right now was poured less than 10 minutes ago. And that same surprising statistic holds true even for the largest size pipe, thanks to what's called a core fibration process.
The manufacturing of large diameter concrete pipe, it takes approximately about 45 minutes to make one of the 120-inch pipe behind me.
As with many sewer upgrade projects, the old interceptor, buried beside the new one, will be kept in usable condition just in case.
That will become a standby sewer so that if they have to do maintenance on the new sewer, they'll be able to move the flows to the old sewer, or if the new sewer is damaged for some reason, they can move the flows into the old sewer.
Once in operation, the new interceptor will provide service to more than 1 million people. It's hoped the 10-foot diameter pipe will meet the area's needs for 50 years. Welcome back to the Sustainable Region from inside the Breakhead tank at the Capilano Energy Recovery Facility. Well, that's it for today's show. We hope you enjoyed it. We'd love to hear from you, so you can call us at 604-436-6794 or email us at sustainableregion@metrovancouver.org. You can also watch our videos online at www.metrovancouver.org/videos. For the Sustainable Region, I'm Vanessa Timmer. Thanks for watching.